the technology to be able to do this on your smartphone. And so that's how I founded this software company called FieldGuide. And what FieldGuide essentially is simply a machine learning platform. So it's working with image and ID in a way that's going to inform the system to be able to, over time, more accurately identify what the camera is looking at, just like we do with ourselves. And of course, there's a very critical human training component to the whole system, but it's taking advantage of the what's really coming out of the best work within AI to be able to make this whole thing possible. And so FieldGuide is kind of getting started, entering with a partnership with Symbiota on the data community side, as well as Visipedia. It's a project housed within Caltech University, working with them on the algorithm side to really try to experiment with all the existing and available frameworks to make image recognition possible. And so with that, I've been working with Neil and Ben and others to develop what we're calling LepSnap for the LepNet project. And so LepSnap has a couple goals. Of course, it's articulated in the write-up about LepSnap that is available to everyone. But I was also kind of developing something that was going to evolve into LepSnap that actually started with a completely independent mindset of what the app needed to accomplish. So I think there's kind of a merging of two different perspectives. And so one of the shared ideas of LepSnap is quite simply that you want to be able to publish photos from your smartphone or from a library that you add to your smartphone really fast and with total ease in 3 steps if possible or less. Another goal was that this actually could be a Venn diagram overlap between the professional world and the amateur world. So it can kind of serve the citizen science community as well as be extremely useful for collections management within institutional collections. And so let's try to create something that is of utility to both worlds. The third thing is that let's try to create a system that can make it really fun to crowdsource expertise around training this image recognition system, because there is this really important human-aided element. I mean, as I got this program up and running, I often discovered that the system recognized and matched with the correct image, but that image was placed within a species that was incorrect. So it's always about making sure that we have correct training data, and that it always starts with the expert being able to give you that reassurance, and that is not only necessarily one expert, but many, and that ID changes over time. So how do we keep up with the constant evolution of the taxonomic system in and of itself? So that's a really important key, is to ensure that the software can drive a very efficient and effective, if not fun, way for people to be involved and be able to be very time efficient in terms of how they can help train the system. So I'll show you what that really means in the actual live demo. The fourth goal is, again, this is an independent software application in terms of what has been configured to inform image recognition, but it needs to play with what's going on in the field. It's sitting on top of LepNet, and therefore we need to ensure that we're following the same rules. That, being able to if someone's entering information, that those data fields are Darwin core and that they go back to the right places. So data portability is really important, and shareability through the app as a mechanism for sharing is really important. And then finally, all this can come together and create a world-class AI, not only on the image recognition side, but over time on other machine learning applications in terms of being able to read and recognize data labels and also predict what is the most likely fields that someone is entering given other contexts or other information. So we're starting with image recognition, but hopefully we can expand into other areas, even being able to have someone just speak into the phone and give the notes verbally, and then it will transcribe it into a record, things like that. Fortunately, there's a lot of the same practices at play to be able to recognize speech as there is with image recognition. So there's a lot of fun things that we can do in the future. But just being able to start with having the machine help getting you closer, providing a really solid hunch as to what the ID can be, can not only help cut a couple steps out of the process on the collections management side, but it also can be a really useful tool for citizen scientists to be like, answer that question, what is this that I'm looking at? And be able to bring people to view museum collections in a way where they can confirm and learn themselves how to identify moths and butterflies. So with that, I'd like to give you a live demo of a couple things that the app will do. The app right now is in what I'm calling the alpha version. So it's not live, it's not launched, but it's in a state that those who have an iPhone can participate in this first version. We're going to be developing both iPhone, iPad, and Android. So we've started with iPhone because the platform is actually a little bit easier, at least for me and my team to develop on, but then we're going to go from there once we roll in all the feedback and from participants on the iPhone. So that I will see if I can get this running. All right, can you see my phone? Put it in the center. Okay. Okay, so the app the the, the black here is the Snap app. So when I launch that, you land on a stream. This is very similar to like a Facebook news feed or a Twitter stream. In this case, this is a following stream. So it's not only photos that I just like things that you would post on Facebook on your Facebook news feed, but also people that follow us. We could be following other individuals that are part of the same collection, or follow other collections, and you can customize it in whichever way. You'd like. And so you can kind of scroll down through that. And then you can view each individual unit of contribution, which I'm calling a figure in this case, like figure A, figure B, figure 1A, figure 1B, is the unit of contribution. This is actually working with the Merrill for the Pacific Northwest want site. So this is these beautiful examples. Yeah. So let's. No. You know, the system will actually put to display not only smartphone images, but images that have been added through desktop as well. So these are published desktop images. Um, And yeah, so we're working with Merrill to be able to add image search to the Pacific Northwest model website. So people can use that as an alternate to the identification key that they already have up there. Um, anyway, so you can go through each of the figures. You have your data set on here. And of course, the most important piece is just how to publish it and use this as a publishing tool to add photos to in this first example. Existing LepNet records. So arm with the couple sample obviously, this is very quick package way to do things. The other methods that are going to produce better smartphone results. But what I have here is, you can see, is a pin specimen. I put a gray card behind it. Obviously, you can find a way with glass and putty to distance the background, so it's more out of focus than what you're going to see in this particular example. And what I've also done is, and I'll add this to the notes for the presentation, some of the supplies I use. So there's really two main tools that are useful for this. One, there are these LED panels. You can get these on Amazon. They're inexpensive. They're just, you can buy the separate rechargeable batteries for them. They have various color temperature, but you can put it to full daylight, so you can really have daylight calibrated color temperature with the gray card, which makes it pretty easy to do white balance. And you also, oh, pardon? It's called Best Light. And you could even loop a piece of simple paper over it to make it even more diffuse light. But I think that these panels are pretty soft in terms of their lighting already, which is great. I also, depending on the phone that you have, you can purchase these little attachable lenses, so that if you have really small, micro LEPs, you can slide that over and be able to. It's amazing how close you can get to the specimen. Now, of course, one of the challenges when you get really small is that no matter whether you use a smartphone or an SLR, you have the depth of field issue, where the smaller it gets, the more you'd like to use image stacking to actually create something that's fully in focus. So it starts to taper off, but I think that for most LEPs, it's still a very useful strategy to get something in focus and actually visually useful. And so I'm not going to use this because I just got a new phone, and I realized that, of course, every iPhone changes the way that their camera fits, so this thing is rendered redundant or useless. But
it is one of those things where smartphone attachments that could find out who uses what. So Anthony Chattanooga took a picture of the micro LEP with one of those. It was really impressive. So I think we might actually already be there to get some really good shots, even of micro LEPs.
The newest iPhones their camera is amazing, and I heard that the Google Pixel camera is even better than the latest iPhone. So there's these top-of-the-line smartphones, and I think that it's pretty amazing the megabyte resolution on these. You can actually take a photograph with a lot of components in it and still zoom in and have a high enough resolution image that it becomes useful. Whereas rewind 5 years ago, and then it's most likely not the case. So okay, so the step to publish a new photo. So I'm going to pretend that there's already a digital record within LepNet for the first scenario here. And so this is just a part of being able to attach that photo to an existing record. So what you would do is you hit the plus icon in the center here at the bottom, and then it will open your camera, and then you try to fill the frame as best as possible. You hit the blue button, snap it. And then what you're seeing right here is a couple things. So the icon in green that's highlighted is your history. So it will show you the species categories you've already cataloged to right here. But then what the system does is it's still, I don't know if the internet connection is slow or what, but it's analyzing the image, and it's also going to automatically put forth the recommendations for the species based on the image itself. So we're taking into account a series of algorithms that tries to identify what's important within the image, and takes that information and tests it against our neural network of sample training images to come back with an ID suggestion. And go ahead.
Will it work with the partial image, like if you got on a flower, you don't get half the wing before it flies off? Will it work with the partial image?
Absolutely. It's really interesting. Sometimes I've tested this against sample images where someone thought that this moth was cool and it was a Luna moth, but they're only photographing like the head view where it just got the kind of bat-like ear antennae and like that front view, and it will actually recognize that if there is some sample images that are useful to the reference. That's the only trick. Obviously, it's going to be more accurate if there's partial wing images and training data, but probability still could be high enough where a wing could bring upon correct match, even though there's not an individual image of that wing within the reference set.
So I think there's also like great potential here for all kinds of stuff. I'm curious to know in terms of moth data. You go outside, see moths that are lights and stuff. Could we, is the idea to ultimately take pictures on your phone, without lights like that, and get data, capture data that way, and then incorporate that into, I'm just thinking, in addition to what we're doing for...
Absolutely. I've tested and I've used this just moth photography where I'm just using the standard flash. And it's great, especially since it will learn over time collection sites, and it will not only retain the GPS location that obviously is encoded into the picture, but it will use your collection site label over time if you have a specific name for it. So there's a lot of neat things that are already working that we can build upon. So it gives you suggestions below here. I think that the first suggestion is correct, but it will continue to serve the best matches, because even if you don't get the correct answer the first time, you may still find it a couple down the list. And also, what happens is if you think that it's the correct genre but not the correct species, then what you can do is you can tap on a result that is kind of near it. Hold on, my loads here. I don't know why it's so slow. And then what you can do is you can move up the hierarchy by either sliding it or tapping on, let's say, the genus level, and it will. In a moment, I'll show you. If I'm not quite connected to Wi-Fi here, it will suggest all the categories that you can browse through, but then it will also match the best images within that particular genus. So it's a way for you to kind of bounce back and forth between helping the system along a little bit by isolating what it's matching against, or you can just match it overall. So when you find the right match, then you tap on that. And anytime anyone else has published an image under that species, you'll be able to look at all the images that have been published to confirm that it's the right category. Then you tap the blue check mark in the top corner. And based on that ID, you'll be able to see that there's a lot of identification fields that are pre-populated. You have your ID fields, so that's common names when available, scientific name, who described, if there's a species number, a Hodgins number, or a P3 number, that will auto-populate in there. Not only that, but if you scroll down further, there's an opportunity to have it be pre-populated with what I'm calling encyclopedic information, or Wikipedia type information that is, just about the species in and of itself. This can be group edited by experts, and that's a completely different discussion and just kind of a nice-to-have feature, but that's there as well, so that when people view individual specimens, they can actually learn about the species as well as the information about the specimen. But what you can enter in here is the dates and the location will auto-populate. And then you can also tag it, like this was a preserved specimen, and it was adult, and I'm not quite sure what gender this is, but we can say it's a female. And then when you're finished entering that information, you hit the check mark, and you are able to publish that image.
I see there was a place for catalog number. You could assign a catalog number to that image.
Yes, I'll show you that in a moment. Well, as that's loading. And an alternative is, you can see that there's an icon right here in the bottom corner. If you tap on that icon, you can enter a catalog number. I'm just going to do a demo one. And once it reads it, it will automatically attach that image to an existing record. And then you can publish it that way. And what we can do is we can have a two-way communication between the desktop portal data set and what you can enter and edit on the phone, and be able to have yet another method to be able to curate your information.
Is there a way to have images of data labels associated with two pieces?
Yes. So there's two different approaches. One, the camera itself is going to have built into it, not into the camera itself, but the screen. It's going to have a QR code scanner. So in any case that there's you're placing the labels alongside the actual specimen, it will read that, and automatically, if it is a catalog number that we can sync to, it will automatically attribute it. You don't even have to type anything in. It will just read the image and hone in on that and use it. But then what you can do is you can also take additional images. You can see here that there's, plus you can add dorsal, ventral view, and then individual label views. So it's really up to you whether you add the full, the full Monty within a single image, or you just photograph these things piecemeal.
The date is misleading. It should be date for take a year, 1st of November. It's not the date that the specimen was.
Yes, no, that's really good feedback, and that's why this is certainly pre-launch. Because we have to get everyone's feedback in terms of how the fields should be communicated, what the titles are.
But that's a good catch. On a wild image that you take on a flower.
Exactly. Sometimes the photo date matches, and sometimes it's completely different. Same location. Obviously, Tennessee isn't where the specimen was collected. So we have to navigate some of those discrepancies.
So two questions. One is great. This is really cool. One is how does your algorithm improve on other approaches to the same problem that have kind of done well with kind of big showing things, but not that very well on little things. And two, so you showed an example of something we discussed last, which is if your collection provided a specimen for that image, how are you acknowledging that? Which seems a pretty core part of the approach in terms of where does feedback go back at the end of the specimen was used to help identification.
Yeah, so that's something that I'm going to be interested in working with Ben to navigate. Right now, what I'm showing you obviously isn't connected from an integration standpoint to the way that data is organized within LepNet. However, I think that the way that would be the right way to approach this is that when you look at specimens, that instead of the individual author, like you see here, Meryl, you actually have the collection as the author for that record. And then what you can do is you can have individuals who are from a permission setting within LepNet. Sorry, it's really annoying.
No time for Kelly.
It's my wife. But anyone who has permissions to be able to add new specimens to that, or add photos or edit existing records can have access to that, and then you can track who made what changes within that record.
Just use this as an example. It can be complicated. In that particular case, narrow the picture and create a record, but that is our specimen.
Yeah.
So it's a more complicated issue than just talking about who gets credit
Well, I think it's all kind of catalog, right? But you could put all of that in field words down the corner. We can take care of the application for using specialists.
What about copyright issues with photographs that were taken funding that say wasn't NSF funding?
Well, any images, any image that goes into a LepNet scheme is Creative Commons. So it's different. We run different than law photographers group with Ramona. If you participate, you agree to have it relatively publicly available. It's not.
But with attribution.
With
attribution, but the question
with
is,
attribution,
where does the attribution go? Does it go to LepNet or does it go to Merrill? Does it go to the museum that provided that?
Yeah, and I think that it can go to all of them. I don't necessarily care about them, except that NSF needs to be really is the bottom line for attribution for us. But
So right now, we have one field for photo credit. But what I think that we need to do is expand all the different kinds of credit that you need to provide for a specimen that's always available in the record front and center. And that also is different from who the user author is in terms of who's published the image within the app. So these are things that absolutely we need to navigate and sort out before something is ready to face the public.
Was there a way to create sort of a watermark when you put photographs of take a photograph of specimen from your collection that is over-stamped, like your collection's logo or something, so people would know where the specimen was held besides the catalog number?
Or a standard collection effort?
It's absolutely possible. Yeah, I mean,
That might be a solution.
yeah. So I mean, there's a couple things there. One, what hasn't been built, but is I think relatively straightforward, is to say, hey, you can upload a watermark file, and then it automatically we can create a program that automatically applies it to the image itself. That's just something that can be done, but isn't done. But then we also have data fields such as present location of specimen, and you recognize both the full name plus the short form name of the museum that specimen is housed
but
in.
I guess I would still say for our NSF project, I want to make it so you cannot upload other questions to the catalog number. That catalog number will link to everything, including attribution. Now, when you talk about watermark and stuff like that, if I could just get a couple of things. So this program primarily pays us 11% of our budget goes for added value. I think this is a huge success so far. But you just have to remember, everything that you want added then goes with the Toyota. It costs money. And then you have the problem of, if you have 4-H volunteers using smartphones, and you go, wait a minute, you didn't put the watermark. I'm just saying, when you do that, you potentially add complications. I really been trying to make this relatively simple, simple as possible. But in terms of a success, this so far is amazing because we started this collaboration with the primarily from Caltech, and Andre was persistent because this is absolutely devoted to an essential need. But the one thing that Caltech said they wouldn't do was they would not do the app part. Well, Andre and his partner comes along, and that's one of the things they wanted to do is the app. When we went back to Caltech and said, well, Andre and Caleb are going to do the app, but they're also really interested in computer vision. And the Caltech people have been so far just absolutely wonderful. So what they want, and they haven't asked for $1, basically want their algorithm, right? So they're working wonderfully with Andre to plan to develop really nice algorithms, and he's going to take care of the app part and work with them to make it all work together. And
I'm wondering, so more and more images in their library, they actually start to break down because the complexity increases rather than decreases. So having noticed that, as you get more stuff, that instead of localizing and strengthening the application, it actually weakens the application.
Yeah, it really is a kind of an accuracy curve where everything feels really wonderful at the beginning,
Right.
like I said. And then it dips down because it's about how many different categories you have and how many images and how those images, the training images are distributed among categories. So, for example, you could add, 200 Luna moths, and then you have, one tort. Well, even if it's a really good match to that one tort, it's weighted by how many training images are available for Luna moths. So there is this very difficult time, kind of middle zone, where it actually feels like the accuracy is taking a hit. However, it does recover a lot when you have really a good number of representation. And what we're doing is we're also adding some load balancing tricks. This is a problem in the computer vision world that is still constantly being grappled with. How do you kind of deal with the bias that's introduced by how many photos are represented in one area but not another? But we have a couple tricks to be able to try to kind of equalize that by detecting what's the most useful reference images within the set that's actually producing the best matches, and then weighting those more than the less useful ones. So you're gonna when you actually take photographs of standard poses for pin specimens, like kind of, I guess you would call it like a vertical head at the top orientation of a spread moth, or even when you're photographing perch specimens of a tort, you do like the lateral view of the side of one that's on a moth cloth, and you create a kind of horizontal view. Those are going to perform exceedingly well, even when we have lots of images. In fact, the more images, the better. But then some of the obscure angles will start to still produce the problem that you're speaking about.
Are you sure of that? Because at OSU they did a project where they looked at preoperative, and they did huge multi-metric analysis of these spinning preoperative in liquid, taking like huge numbers of data for each specimen. As they built the data set, they basically began to crumble. They were incredibly accurate at identifying the library material, but as soon as you took a stone fly with the same species from a nearby creek, because the data set was so accurate, it couldn't recognize a conspecific from a creek photo. It was that accurate. So finding the line between that became more and more challenging as the data set, the reference library got more and more robust.
Yeah, well, there's three things that we're doing. Obviously, one is the incentive to try to engage the community to try to provide a diversity of photos, obviously, but that's not always practical. That's the first thing that we certainly want to encourage. The second thing is that we're working on applying kind of what's called good old AI practices that are symbolically based. And so it's really focusing on getting really good at recognizing the moth or the butterfly in the scene in a symbolic manner in order to get really good at having a broader understanding of the different poses and behaviors of that, and not being so heavily influenced by different backgrounds and contexts and lighting. So that's the second thing. And then the third thing is that it's just amazing how much better the neural net systems are getting. We're right now hosting this on your classic cloud Amazon Web Services server infrastructure, but soon we're going to be taking advantage of some of the hardware that Google is developing for a project called TensorFlow, where the actual hardware itself is designed from the ground up to service this machine learning model. And it's amazing how that in our testing, and again, we're going to try to produce some sort of quantifiable results, like here's what we've done, here's how you can experience, or have set appropriate expectations for accuracy. But it's pretty amazing, like night and day difference in some cases, the performance of these new neural nets that we're dealing with.
Yeah.
But you're right, it's still a tough ongoing problem to
Yeah, but it's not the experience of Wikipedia's of having birds.
But the diversity of birds is so much lower. I mean, when
It's still not, compared to like copters or cars. And I mean, then for our last last time I talked to Grant, he said, they're better than the best routers at being able to identify an image with no, with past.
Yeah, I think that the main thing is isolating. What's still tricky is understanding what's important within the image scene and being able to hone in. So what the system does right now is it uses a family of algorithms that really make a best guess. And then we're going to be adding an interface for humans to be like, no, you're looking at the wrong part of the image, because that happens sometimes. These images with these color bars, if there's a speck that's a micromoth, and then you have the giant color bars and rulers and labels, it will be pretty impressive if it doesn't hone in on the color bars or something that's not, that's a more dominant feature with the image. Now, that's a separate problem that we're going to be focusing on trying to attack. Like, how do you create a system where you can create things that are recognized to omit from taking into account for image recognition? And that's a really fun project that I was talking about briefly with Grant that will kickstart soon. But it's just a big problem. It's certainly going to be good enough for some things and kind of hopeless for other applications right now.
But your tests are as good as VisitPedia so far.
Yeah, absolutely.
And so the VisitPedia people, they're not biologists, they're software engineers. So when we first tested these RTMs in the Northwest, they didn't think that it would separate field images from good specimens. And they still got really good separation from field images of butterflies and all kinds of images from green foliage. I was truly amazed.
What I don't seem to see in the fields that you've included is one place where a reputable taxonomist may give his endorsement to the determination or change the species name, because right now it's an automated identification, which in the case of species complexes, it's only as good as the software as species variation. So you need, like if a taxonomist in that genus can go through all the images and use the data for publications, then they can kind of hardwire identification that will no longer change and that will bear the taxonomist's endorsement.
Are you guys familiar with the app Tinder? For those that are not, it's just a way where you put in your profile of who you are and what you're interested in, and it match makes your interests with people that it predicts will share those interests, or your profile will if it's their interest. And then there's this quick like swipe yay or nay you're interested. You kind of review people's profiles, and it becomes a kind of an almost gamified, addicting way of if both of you swipe in the right direction, then maybe you're ready to meet them. So I want to take a similar method to the training system for image recognition. And the way that, again, this is completely open to feedback. This is just a brainstorm. But right now you can create custom streams within LepNet, where not only can you say, I want to go to my home page or my home screen is just people I'm following, or I want to see everything in LepNet. But I can go very specifically and say, I only want to see noctuids from the state of Missouri, the catalog in the state of Missouri. Or I only want to see one species, no matter where it's cataloged. When you create these streams, what you can do is you can also opt in to participate in what is called a review queue. And when you do that, it's a simple flag on that screen. And then we haven't set this up, maybe weekly, monthly, maybe give the user the choice. They can get a summary of the latest images that have been published to that screen. And it becomes a quick and efficient Tinder-like process to say yay or nay on a correct ID that attributes your confirmation as an expert to that species identification. Or if you reject that identification, it can maybe move up to the genus level or even above. Or you can suggest right then and there an alternate ID, and it can change. And then there's if that change happens immediately, or if it's a change that occurs on approval of the original author. So I can show you what that looks like kind of in a demo here. So the icon on the bottom here that it is that is your kind of your alert. You know, if someone's following you or is commenting on a figure. And there's this other icon called that I'm calling the review queue. And when you tap that icon, I'm pretending that I've already set up to review a certain kind of stream of MOFs. You see in the top corner, you have 5 MOFs to review. These are the figures of each MOF where you can see all the information and 1 or more images each. And at the bottom here, you can reject that ID, you can change that ID, or you can approve that ID. So I can reject this ID, it slides down to the next one. I can say yes on this one, yes on this one. I can hit the triangle in the center and enter that category view where I can assign it to different species levels.
And it will act you as the person.
Correct. Correct. And so you can quickly swipe through and confirm that, and then when you're done, that review queue is done, and you'll be notified the next time there's a critical mass of items to review. So that's in your back pocket. You can take out your phone and do that when you're waiting for the bus, for example, which could be
There's
useful.
another thing that you might
able to drop an image of, one off of their screen and be able to see the image of what's loaded on the Pacific Northwest site. Click on that, it will take them to the species fact sheets page where they have all the information about it. And so it really is just a visual search implementation that serves the site itself with not much to do with the LepNet or the LepSnap app at all, but it's just taking advantage of all the information that's being gathered to inform image recognition. So that's just one of the side projects that benefit from this work, which is great. Another thing is that anytime that there's a website, obviously anything that's uploaded on LepNet, so get a LepNet portal page and published through there has a potential of making that visible in your back pocket through the LepSnap app, and that there'll be a web link to that web page in the app itself. Like just when you're seeing a specimen, you just click on it and you're able to view that, that page and jump to it. But that can also extend beyond the LepNet portal to any sort of other third-party, museum pages, any HTML that you want to add to any record there. The other thing I forgot to mention that is a problem that is not completely going to be sort of the beginning because it's a little bit of a big data problem, but it's something I know is critically important. That is taking into account elevation, flight time, or for caterpillars, their time, and location, and being able to take advantage of all the dependable distribution data out there to increase the probability of likeliness to inform image suggestions, because what we see right now is this can be easily global. Someone can upload an image from the backyard in Australia, and there are some species that look near identical and they're coming from completely different parts of the world, and right now we're just going flat on appearance, and so you're going to get a mixed bag. But that is one thing that we're tackling, and there's certainly opportunity to create isolated apps, independent apps, that already filter out that stuff. So you know that when you open that app, you can actually, you're only going to get suggestions for things that are going to be found within that group or that area. So real quick, just to finish up, how to get involved. Participate in private beta. Anyone contacting Neil can be connected with this project, and then we can get this app on your phone tomorrow. It's already ready for that. Just know that all the information that's on there right now is not publicly viewable. It's really just for the purposes of understanding how this behaves, but it'd be good to know what should be ultimately publicly or privately viewable. Contribute training photos, even if you can't use the app itself, knowing that there's new opportunities to get new training data in the system. Become a reviewer. Again, it can be a species, like you can say,